Hi friends, my dear students. In last class we have seen of life of any radioactive substances. But now we are going to see mean life that is called tau, TOW, tau, that is called mean life. What is my mean life? The definition of half life we already seen. The time required to decay or half of the number of total to be, if suppose when total is n naught, then n naught by 2, the time taken for this is called half life period. So how can we explain the mean life? Suppose mean life is entirely different from half life. When radius nucleus undergo the decay, or radius of any nucleus are undergo the decay, then nucleus which disintegrates first. Suppose if you consider any nucleus, if it is decayed means the first decayed nucleus has no half-life. Then last one is decayed is called infinite years. That's the thing that you have to understand. So the major concept you have to clearly understand here, when the radioactive nucleus undergoes the decay, the nucleus which disintegrate first integrate has zero value, and the last one which has decay loss an infinite lifetime. An infinite lifetime. That is a very very important concept that we must clearly first. The first decay lifetime that is equal to 0. That means the nucleus are possess 0 to infinite lifetime. That's the thing. That's the meaning of this nucleus. The nucleus has a time of 0 to infinite. We cannot be able to fix. We can, if you say carbon, then it has half life. Definite definite value of T of. But when you say general, then 0 to infinite. That's the thing that we have to understand. Okay. Now, how can we explain the half-life? The actual lifetime for each nucleus varies from 0 to infinity. Okay. Now, it is very essential to calculate T of is more valuable than more valuable than mean life. Sometimes mean life is most essential than the half life. Mean life is nothing but in between 0 and infinity we can calculate the total lifetime of initial to the last. You have to add sum of these, then divided by total. That's the ratio between these two things. The ratio of the total ratio of the lifetime, total lifetime of all nucleus, all nucleus, all nucleus by the total time of life, the total lifetime of all nucleus, or you have to integrate, integration of, integration of lifetime. Integration of lifetime means you have to integrate all the, by means of 1, we can integrate this value, then we can get the total lifetime. That is why total lifetime of all nucleus or integral of nucleus. Integration of one nucleus. Integration of one nucleus. This equivalent to the total lifetime of all nucleus divided by total number of nucleus. This is called a ratio. This is called a ratio. Is called mean life. This is called mean life. Mean life, which is nothing but the ratio between total lifetime of all nucleus are divided by total number of initial number of nucleus. That's the thing that we are going to derive an expression for that. Now we have to assume the time t, between time t and t plus delta t, within the period of time, the decay may happen. Okay, and amount of decay is equal to r into delta t, This is a valuable equation, r into delta t. But we already know what is the value of r. R is nothing but n naught into e power minus lambda t. N naught into e power minus lambda t. Now we need r delta t. Therefore r into delta t, that is equal to n naught into e power minus lambda t into delta t. Okay, this is the equation number 1. Now it may be prolonged up to t years, up to time t. Therefore t into r delta t is the total value of decay time, mean life. This is called mean life. Mean life is called tau. Now we want to find out the value of t or delta t. Now we have to explain what is meant by when tau. This is called mean life. When t equal to 0 and t equal to infinity, within this time duration, if you want to find out the decaying time period, that is called tau. Then you have to integrate this value. To the limit of delta t tends to 0. When delta t tends to 0, then mean life is nothing but integral of this value, integral of t into r delta t divided by total that is equal to n naught. This is the value. Here the time taken, here you have to apply time taken, limit for integration 0 to infinity. This is called mean life. This is the integration of total nucleus by initial nucleus. Ratio between these two is called mean life. Now I want to explain this. How can we obtain this equation for mean life? Tau. What is the value of tau? That's a very important concept to explain this concept. Now here, when the value of integration of t or delta t is nothing but, we know the equation r that is equal n naught into e power minus lambda t, or that is equal to n naught into e power or that is equal to lambda into n naught e power minus lambda t, or activity value. Therefore here you have to substitute here, then 0 to t, 0 to t, t or dt means you are integrating, that's why it may be changed as dt, not delta t. Integration means you have to change dt, or instead of r you have to substitute lambda n naught e power minus lambda t into dt. This is the integration divided by n naught, divided by n naught. You need not bother about to solve this equation, and that is not essential for your examination as far given in your textbook. In your textbook they told that you have to calculate this value itself. You need not bother about the steps. If I want to explain these steps, there are more than half pages. I think it is very difficult to understand this reducing method. That's why straight away we can get the answer. Straight away we can get the answer. If you are integrate this value, then we get n naught by lambda. That's all. N naught by lambda, or sorry, tau, that is equal to 1 by lambda. Tau, that is equal to 1 by lambda. This is the equation. Here n naught cancel, and both there are more than 10 steps are available. Then after that you have to substitute the limit, then we get 1 by lambda. Tau, mean life, it is nothing but reciprocal of decay constant. Reciprocal of decay constant. This is the mean life. This is the mean life. Now, using the mean life, the half-life can be written as, using this mean life, the half-life can be written as T of that is equal tau natural log of 2, tau natural log of 2, natural log of 2, that is equal to 0.6931. 69, this is equal, we already calculated the value of natural log of 2, it is nothing but 0.931. Now it is multiplied by tau, it is multiplied by tau. That is the most valuable equation of T of. That is, T of is nothing but tau multiplied by 0.6931. This is the most valuable equation of the half-life period in terms of mean life. This is half-life, this is called mean life. The relation, what is the relation between half-life and mean life is given by the equation is T of equal to mean life into half-life equal mean life multiplied by 0.6931. This is a famous equation that you have to understand. I hope you are bothering about these steps. I can explain, but I think it is very difficult to understand the concepts as explained in your textbook. That's why not essential for your examination also. That's why simply you can put, you have to think about lambda itself, tau, here tau, then reciprocal of this value, remaining all forget, 1 by lambda, that's the answer. Then half-life can be written as T of tau into natural log of 2, natural log of 2, therefore this is a natural log value and multiplied by mean life. Then finally we get T of is nothing but mean life multiplied by this value. This is a very important question. for 2 mark or 3 mark questions. It may be asked. I hope you may understand clearly. And next class we have to mm, remaining the whole portions are this chapter going to finish within 3 days. After finishing this chapter, next very important chapter, the electronics, are the basic, very essential for in future life. If you want to enter IT field or if you need any job, then you must know what is what by valves to microprocessor. First generation valve, valve, valve. Then um, semiconductor, semiconductor, semiconductor. Third one, third one transistor, third one transistor, and fourth one is the integrated circuit. Then microprocessor, microprocessor. Now this is the valve, first generation, second generation, third generation, integrated circuit, microprocessor. Now silicon, silicon is the semiconductor. Transistor is also on the basis of diode, triode, tetrode, pentode, like this. Here transistors are NPN and PNP. PNP are two types of transistor. Likewise, you have to call the IC, that is called chip. Chip. Then all the data supercomputer. 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 Now we are in the category of flying in this category. These are all things that we are going to study in the next chapter. There's a very important chapter for this 12th syllabus. I hope you have to wait for 3 days. After that, I have to explain one by one clearly. And last chapter is the communication. Communication. How to communicate. Suppose I want to communicate what I have thing in my mind to you through media. That's a very important concept. These are all things that is going to be finished within 15 days. After that, again I came back to the 6th chapter and first volume. And thank you, my friends.